and this is delta. So okay, you don't need this. I have just written it. I mean, all the JE guys will need it certainly, and they should actually know it, not just need it. They should remember it by heart, that how to find out whether an equation belongs to circle, parabola, ellipse, or hyperbola. But for CBSE, we don't need this equation. I have just written the equation with proper information, and I have also mentioned these three cases. I mean, how to find out whether this is a parabola, ellipse, or hyperbola. So for circle, we have already discussed that coefficient of x square must be equal to coefficient of y square, right? And coefficient of xy term must be 0, right? And we have also discussed some examples for this. But and we don't need to check delta, by the way. This delta, we will never, I mean, there will be no question which needs this much of information that you need to find out delta and then you will define this. No, that won't happen. So just these cases will help you. So remember this thing, that how to, I mean, if an equation is of 2 degree, then whether if it's circle, then it must satisfy these two conditions, right? Now, similarly, let's go for parabola. In parabola, h square must be equal to AB, but this definition won't I mean, work for you guys. And why am I saying this? Because you won't be able to, I mean, judge quickly whether this belongs to parabola, hyperbola, or ellipse, because no equation will be given in this form. They will just provide you simple equations of parabola, ellipse, and hyperbola. So rather than h square is equals to AB condition, we should remember this condition which I'm writing right now. And the condition says that either, okay, so before this, I would like to define 4 standard type of parabolas. And these equations are, so 4 equations
So,
which will be used. Yes.
so what is delta?
Yeah, Shagar.
What is delta, sir?
Uh, delta is basically, so this second degree equation not just signifies these 4 things. It also signifies a pair of straight lines. You must have read pair of straight lines in IIT JEE syllabus, I guess.
Yes.
I mean, yeah. So how to find out whether this second degree equation can actually be represented? I mean, this will represent either of the 2 figures. Either it will represent a pair of straight lines, or it will represent conic sections. If you remember, in class 11th, we have this chapter conic sections, which basically include all these 4 types: circle, parabola, ellipse, and hyperbola are collectively known as conic sections. So this second degree equation either will represent pair of straight line or will represent conic sections. Now, how to decide this? So this delta is basically a numerical measurement which tells us whether a second degree equation is pair of straight line or conic section. If this delta is equals to 0, then it will represent pair of straight line. If this delta is not equal to 0, then it will not be equal to, I mean, then it will represent a conic section. Now, after delta is not equal to 0, you will have to check other conditions to find out whether it is a circle, parabola, ellipse, or hyperbola, right? So this delta is basically, now how to calculate delta? Delta is basically a determinant whose, if you observe, whose diagonals are a, b, and c. A, b, and c mean coefficient of x square, coefficient of y square, and constant term, right? And this is a symmetric determinant, if you observe, because these 3 elements are h, g, f. These 3 elements are also h, g, and f. So you can remember this delta as ABC are the diagonal elements, then HGF upper side, upper triangular, and HGF in the lower triangular, right? So that is how you can, I mean, remember how to calculate delta. And delta will basically tell you either it is a pair of straight line or conic section. If delta is equals to 0, then pair of straight line, and if delta is not equal to 0, then conic section. But we don't need that for CBSE syllabus, obviously. I mean, this is even not defined in your class 11th notebook. So that is why I have written this, because I knew that you haven't heard about this. So this is the proper definition, that how you can check whether a second degree equation is parabola. I mean, a second degree equation represents what? I mean, there are multiple figures, there are multiple things that can happen in a second degree equation. And these are just the measurements of them, right? But we don't need this. Why did I say that? Because I don't want you to calculate delta for every second degree curve, because you will never have pair of straight line. You will never have pair of straight line, right? Because pair of straight line is basically not in your syllabus. Conic sections is in the syllabus of CBSE, but pair of straight line is not in the syllabus of CBSE. So you will not see a single pair of straight line. I mean, a single second degree equation which represents pair of straight line. That is why you don't need to calculate delta. You can just figure out these conditions. So for circle, this is the condition. These two are the conditions. Now for parabola, so parabola will be represented generally in this form, right? Now in this form, how to understand this form? I mean, either of the x square or y square will be present. Both simultaneously will never be present in a parabola. Either y square will be there or x square will be there. First thing, okay? If y square is there, then x square won't be there, and x will be in 1 degree. And if x square is there, then y will be in 1 degree, right? So this is a simple, I mean, explanation or simple trick you can use to remember whether it's a parabola or not. And the trick is either of y square. Okay, I'm actually, I'll write it in this form. Just a minute. Yes. So So if y square is present, then x, the terms including x and constant, obviously, constant can be there. So, or if x square is involved, then y square won't be involved. And I mean, one variable will be in 2 degree and one variable will be in 1 degree. That is how you understand that this given equation or this second degree equation represents parabola. Similarly, for ellipse, okay, now for ellipse also, we have these equations: x square plus y square upon b square is equals to 1, or it can be written as x square upon b square plus y square upon a square is equals to 1, right? So these a and b are constants, right? So how to understand what is this equation? Very simple. In this case, both x square and y square will be present. Both x square and y square will be present, right? No term of xy will be there. No term of xy. I'm writing all the general equations and you can check them. These are the general equations. These are the equations that you will see. You will see an equation like x square by 4 plus y square by 9 is equals to 1. That can be an equation of ellipse. Similarly, for hyperbola, x square by 4 minus y square by 9 is equals to 1. That is an equation of hyperbola. So you will see these kind of equations. And similarly, the examples for parabola are y square is equals to 4x. I mean, y square is equals to 8x. Or x square is equals to 16y. Kind of these figures, right? Now we will also understand how to make these figures. But before that, just understand how to identify them. So in case of ellipse, you will find x square and y square both. X square and y square are, I mean, both will be there, but I mean, their coefficient will be different, but the sign of the coefficient will be same. See, this is also positive because this is 1 upon a square. The coefficient of x square here is 1 upon a square. And the coefficient of y square is also 1 upon b square. Both are positive because a square and b square will always be positive, right? So in this case, both x square and y square will be present, but different coefficients with same sign. In this case, both x square and y square will be present. Their coefficients will also be different, but both the coefficients will have opposite sign. I mean, if you remember these four things, four simple conditions, then you will always be able to identify whether this given curve represents circle, parabola, ellipse, or hyperbola. So let's practice this before we go further. I'll write the necessary things about them. But before that, let's try to identify some of the figures or some of the curves, whether they represent parabola, ellipse, hyperbola, or circle. Anji, what is this curve called?
So ellipse.
Ellipse, right? You can see that both x square and y square are present, right? Both x square and y square are present. Both have same sign of coefficient, but the coefficient is different. In the first case, I mean, the coefficient of x square is 1 upon 36, and the coefficient of y square is 1 upon 81. So this is an ellipse. This uh guys, can you identify this? What is this? I mean, are both x square and y square present? If both x square and y square are not present, then तो बहुत ही सिंपल है. I mean, this is directly parabola.
Parabolas.
Yeah. So if both x square and y square are not present, in that case parabola. If both are present, then we will check their coefficients. If the coefficients are equal, right? If the coefficients are equal, in that case, and also term of xy is 0. Term of xy will always be 0, by the way. So you just can understand this with x square and y square only. बहुत ही सिंपल है यार. x square y square से ही पूरा जज कर सकता है. You can find out with the coefficient of x square y square, right? So if both are not, I mean, if x square and y square both are not present, in that case, simple hai, parabola. I mean, only one is present, right? If both are present and both have same coefficient, right? Both have same coefficient. Same coefficient mane if one has 4, then other also has 4. If one has -2, then other has -2, right? Same coefficient, then circle. If different coefficient but with same sign, ellipse. If different coefficient but with opposite sign, hyperbola. Can anyone tell me what is this?
Hyperbolas.
Hyperbola. Anji, what is this? Don't focus on any other thing. Just the coefficient of x square and y square. and this is circle because the coefficient of x square and y square both are same. Tharif,
Circle.
yes, Tharif, Humamuddin, Austin, Shahid, I would like to ask you guys, did you understand this? How to identify which equation represents what?
Sir, can you explain for ellipse and hyperbola?
Yes. So for ellipse and hyperbola, Tariq, we just have to check. I mean, for all four, we just have to check the coefficient of x square and y square, right? अगर
Sir.
x स्क्वायर और y स्क्वायर दोनों में से कोई एक टर्म नहीं है, फॉर एग्जाम्पल मतलब x स्क्वायर है और y स्क्वायर नहीं है, या फिर y स्क्वायर है x स्क्वायर नहीं है, तब तो सीधा पैराबोला है, राइट? अब अगर दोनों एक्स स्क्वायर और वाई स्क्वायर है, तो हमारा ये एलिप्स भी हो सकता है, हाइपरबोला भी हो सकता है, सर्कल भी हो सकता है. फॉर सर्कल we will just check whether the coefficients of x square and y square are equal or not. If they are equal, like in fourth example, then it's a circle. If they are not equal, then we will also see their sign. Like you can observe in the first example and in the third example, coefficient of x square and y square both are different. In the first example, x square coefficient is 1 by 36 and y square coefficient is 1 by 81. So they are different, right? But they have same sign. This is also positive and this is also positive, right? So if coefficients are different, then we will check their signs. If the signs are same, then it is an ellipse. If the signs are different, then it is an hyperbola, like in third example. Third case also, coefficient of x square is 1 upon 16, coefficient of y square is minus 1 upon 9. But we can see that we can see that the coefficients are not equal, but they have opposite signs. That is why this is an hyperbola. Is it clear, Harif?
Yes, sir.
Okay. Cool. Now we also need to know some more things about ellipse, parabola, and hyperbola. So let's start with parabola and then cover ellipse. Hyperbola we will cover whenever we will need the equation of hyperbola. So, but before that, we have to cover these two things. One is parabola and other is ellipse. So let's first cover parabola. And while covering parabola, oh my God, this won't work. Sure. First equation. First equation is y square is equals to 4ax. So first of all, what do we need to know in a parabola? I'm explaining you the first equation, right? And with the help of this, we will also try to understand the other equations, right? So y square is equals to 4ax. I mean, you observe this, okay? If you put y 4, then 4x is 16, right? And if you put y minus 4, then also 4x is 16. So can I say that if I put y is equals to 4 and if I put y is equals to minus 4, then the answer is same for x, right? It basically tells you, I'm just explaining the graph, okay? And it will make sense when you read it. So the graph is like this. And if you observe, above x-axis wala part is a mirror image of below x-axis part. Why this is a mirror image? Because for all the positive values of y, there will be certain values of x. But for all the negative values of y, the equation will produce the same x. That is why for a single x, there are two values of y. See, if you take this point and if you take this point, right? For both, the x coordinate is same, but the y coordinate is different. And why is this happening? You can observe this with the equation. If you put y positive as well as negative, it will produce the same result. That is why the graph is like this, right? Now, what do we need to know about a parabola? You can also write this. I do have some books. Just give me a minute. I'll explain this. Be able to understand from the book. Yeah. So but you can check it from here. I mean, first let me explain. Then for the other forms I'll directly use the book. Yeah. So this is y square is equals to 4x, and we need to know 3 things here, right? So like for circle, we need to define center and radius. So similarly, for parabola, we need to define focus. This is focus, and the coordinate of focus is a comma 0. A, what is a? This is a. Okay. And one more thing is directrix. Now this directrix is at the same distance from this, and this is vertex. Yeah, just 2 3 things. Okay. Okay, so this V is vertex. Vertex is 0 comma 0. Okay, I'm not. Just give me a moment. Draw a table. Sorry. You guys can also form this table quickly. Yeah, so here we are writing equation of parabola. Here we are writing vertex. Here we are writing focus. And here we are writing directrix, equation of directrix. Okay. So first equation of parabola is y square is equals to 4ax. Vertex is 0 comma 0. So vertex is the point, right, where your curve, about which the curve is symmetrical. Symmetrical means, see, upper side of this curve is basically a mirror image of the lower side of the curve. If you divide this whole parabola from the point vertex, then you can easily notice that this is just a mirror image of each other, right? So vertex is the point about which your parabola will be symmetrical, and it will be 0 comma 0 for all 4 equations. We will discuss 4 equations, but vertex will be 0 comma 0 for all these equations. And focus in this case is a comma 0. Focus lies on x-axis, right? And focus is a point. Focus and directrix, by the way. Yeah, directrix in this case will be at the same distance at which this focus is, right? So this equation, just a minute. Yeah. So this directrix equation we can write very quickly, which will be x plus a is equals to 0. We don't need to remember this directrix equation. We just need to remember these 2 things. One is focus, where will be the focus for every parabola, and one will be latus rectum, which I'll be discussing in a bit. Just give me a minute. But before that, understand what is focus and directrix also. So how this parabola is made, I mean, every point which lies on this parabola will be at the same distance from directrix as well as focus. This is how we define a parabola also. Like how do we define circle? Circle is collection of all points which are at the same distance from a fixed point. And this fixed point is center, right? And all these points lie at a distance of radius from the center, right? So a parabola is defined like a collection of all the points which are at a fixed distance from a fixed point and from a fixed line. This fixed line is called directrix and this fixed point is called focus. So if you draw a figure taking a constant point and a constant straight line, and if you draw a figure on which all the points lie at an equal distance from this fixed point and from this fixed line, then that figure will always be a parabola. Right? This is how we define.
Sir,
Yeah.
can you just tell the definition of directrix?
Yes, directrix is also a fixed line. Directrix and focus are, I mean, we don't have any definition for directrix and focus because you can take anything focus and you can take anything directrix. You want to choose any line, that can be a directrix, and if you want to choose a point, a fixed point, that can be a focus. But I mean, for them to be a focus and directrix, you need to draw the parabola. But a parabola can be drawn if the focus, I mean, this focus is not lying on directrix. So if you take any fixed point in the plane, if you take any fixed line in the plane, they can work as a focus and directrix unless the focus is on not lying on directrix. Right? Yes,
Okay, sir.
but the parabola definition we need to understand, which says that, just a minute, I'm writing it here. Collection of all points collection of all points which lie at an equal distance from a fixed point. What is this fixed point? Focus. And a fixed line. What is this fixed line? Directrix. So you take any point on this parabola that will be at the same distance. Let's say this point is P and this parabola is F. And I mean, this is not scaled right now. So don't take it as के ये तो नहीं लग रहा. If this is a parabola, then these two have to be equal. PF is equals to PM. And this P can be any point. I am just taking this point above the x-axis, but you can take any point on this parabola. The distance of that point from focus and directrix will always be equal. Then only we can say that this is a parabola. Right? So collection of all points which lie at an equal distance from a fixed point and a fixed line is called parabola. Now there are four types of parabola. This is one of them. Now the second type of parabola will be, one more thing. Just give me a minute. Latus rectum. One more thing which we need to know is latus rectum. So latus rectum is basically, other than latus rectum, one more thing. Sorry, my bad. We have basically two things. Okay, this is PF is equals to PM. Now, this is basic, the x-axis right now about which the curve is symmetrical. This is x-axis. This is known as axis of the parabola. Axis of the parabola is a line about which the parabola is symmetrical, and wherever your axis and parabola cuts, that is basically vertex, right? So axis of the parabola, and if you draw a perpendicular line to axis which passes through the focus, if you draw a perpendicular line to the axis which passes through the focus, that is called latus rectum, right? So a latus rectum is basically a perpendicular to axis which passes through focus. Yeah. Yeah. So these points, by the way, You should know these points. A comma minus 2a, and this is a comma 2a, and the length of latest rectum is 4a. So I would like to add just one more column to this, which will basically be your two more columns, which will basically represent your coordinates of latest rectum and length of latest rectum. Length of latest rectum is same for everything. I mean, for every case.
So
Yes.
the coordinates of focus is a comma 0, right?
A comma 0, correct. So this is latest rectum. I mean, this is length, or rather coordinates of latest rectum, and then this will be length of latest rectum. I'm writing LR, latest rectum. So length of coordinates of latest rectum in this case would be A plus minus 2A. There will be two coordinates for latest rectum, and then the length would be 4A. Can somebody guess how will this curve be? Y square minus 4x. Y square is equals to minus 4x. We have already studied about one curve, y square is equals to 4x.
So the opposite.
In the opposite side, right? Vertex will again be 0, 0. The focus will be on different side, minus a, 0. If you focus, we don't need to do anything. I mean, we don't need to do any major changes to the equation. We just need to convert a to minus a. So wherever you have used a, just replace that a with minus a, and the equation will be this. I mean, sorry, the curve will be this. The same curve in the opposite direction. Everything will be same. Just replace the a with minus a everywhere. I mean, obviously, we can't replace a with minus a in length because length will always be positive. But other than that, you can replace a with minus a in every equation. Similarly, we have two more equations. X square is equals to 4ay and x square is equals to minus 4ay. You will notice some cool things here. That one, vertex won't change. Another, length of latest rectum won't change. Focus, बहुत easy. We just need to know the figure. If we know the figure, na, we already know everything. Sorry. So this is x square is equals to 4ay. You can also remember this with the graph of y is equals to x square. Y is equals to x square is basically a parabola only. But the focus will be here. I mean, we do know how the focus lies with the parabola, right? So that will help us in finding out the coordinates of focus also. This will be the equation y plus a is equals to 0, and this will be y minus a is equals to 0. The coordinates will be, they will interchange this time. For x square is equals to 4ay. Yeah, correct. So for this, these will be your plus minus 2a. And this will be plus minus 2a comma minus a, right? And these four equations are generally standard equations, are called standard equations of parabola. And fourth I'm drawing here only, which will be like this. You have to draw a rough figure only, by the way, in the whole chapter. I mean, you should know about the coordinates, but not, you don't have to, I mean, scale up your figure. So this is all about parabola. that we need to know. And now let's fatafat come on to ellipse, because parabola won't be used much, as I also told you earlier. So we need to really focus on parabola and ellipse, and also circle. And I'm assuming that you have already read about straight lines, right? If you have a problem with straight lines in the questions, then please reach out to me.
Sir, that chapter was deleted last year.
ओ भाई, ऐसा क्यों करते हैं भाई ये तुम्हारे साथ?
I mean, sir, they didn't teach us last year.
Sorry?
I mean, they didn't teach us, sir.
अच्छा, नहीं मैं तो सीबीएसई वालों की बात कर रहा हूँ. तो यार ये देखो, I mean they have just interchanged the coefficients, but what does this exactly mean is सिंपल ही है, तुम दोनों
sir,
इक्वेशन को एक ही तरीके से देख
Just
सकते हो.
scroll up for a second.
अरे भाई रुक जा. स्क्रॉल अप ही करा कर मुझसे बार बार, यूं नहीं समझ के लिख लूं खुद से, है ना? इतनी देर जो मैं बोलता हूँ क्या फायदा होता है उसका शायद? फिर तो बुक भी थी हमारे पास. ये याद कर ले और काम आएंगे काफी. बार बार यही चीजें बात करते रहेंगे इस पे. इज इट ओके? शाविज, इज इट ओके?
Yes, sir.
ओके.
Done, sir. Yes, sir, you can scroll down.
Now give me 1 minute. I'm eating. लिख अब. Sorry guys. Funny है. Okay. So yeah, so let's start with these two equations. I mean, first of
Sir.
all, these two equations are not different. Yeah.
So like all these equations are taken from coordinate geometry.
Yes, absolutely. I mean, we have already discussed these equations in class 11th, ऐसा नहीं है. We have worked on all the 4 topics of this conic section. But right now, though, I mean, I'm more interested in, first of all, giving you the feel that how are these curves behaving, what, then what are the general or standard equations for these, and how do they look, and then obviously the important points in them. Because they will be giving you ellipse, then they will be talking about focus, latus rectum, so you should know these things. Okay. So this is a horizontal hyperbola, and this is a vertical hyperbola. What is the difference between horizontal and vertical? First of all, what is ellipse? So ellipse will contain 2 focuses. Let's say this is f1 and this is f2, and this is also f1 and this is f2. Let me, I mean, hear me out first of all. Let's talk about, let's think practically first before going to the theoretical definition of ellipse. What is an ellipse? Ellipse is a squeezed form of circle only. So if you squeeze a circle, now you can obviously squeeze a circle from 2 ways here. One is that I am squeezing the circle on y-axis. See, I am applying the force here. तो ये थोड़ा ऐसे फैल जाएगा, right? This will expand on the x-axis. Similarly, if I apply the force here, then it will expand along the y-axis, right? So ellipse is basically a squeezed form of circle, first of all. So this is not a circle, but still it looks like a circle. So as in circle, these 2 diameters are equal. I mean, this, let's say this point is A, and let's say this point is B, let's say this point is C, and this point is D. Okay. So AB and CD, the length AB and CD will be equal in a circle, but the length AB and CD will not be equal in case of an ellipse, right? One will be greater and one will be smaller. Length will be called as major axis of an ellipse, and the smaller length wala part is known as, guys, am I audible? Hello. Yes, sir. Now am I audible? I think I'm audible, right? Okay. So the greater length, which in this case is CD. Okay, for your convenience, I'm writing the major axis as AB and the minor axis as CD. So this point B is A comma 0, and this point A is minus A comma 0. Similarly, this point C is 0 comma B, and D will be 0 comma minus B. So the length of your major axis is 2A, and the length of your minor axis is 2B. Okay. Whichever length is greater, I mean, if A is greater, okay, so let's not go there. Before that, let's take an equation and understand it through that equation. Let's say the given equation is x square by 9 plus y square by 16 is equals to 1. Okay. So first I will observe that, first I will find out that whether this equation is an ellipse or not. How would we do that? We would check the coefficient of x square. They are not equal, but they are of same sign. Definitely this is an ellipse. Right? Now I can see that x square has the coefficient 1 by 9 and y square has 1 by 16. So I will compare it with the standard equation. I will write x square by 3 square plus y square by 4 square. this is my ellipse. So how do I know which, I mean, this is horizontal or vertical? Very simple. Whichever coefficient, I mean, whichever denominator is larger, the graph or the curve will represent the same thing. So if coefficient, I mean, the denominator of y is large, in that case, it will be a vertical parabola. And if denominator of x is large, in that case, it will be a horizontal parabola. And similarly, you can see that the major axis, length of major axis in this case is 8, because major axis will always lie. I mean, this major axis and minor axis will both be present for this, but length of major axis will be 8 2a, and length of minor axis will be 6 in this case. If I want to draw this figure, I know how to draw this figure. So we will take no, my bad. Sorry. Yeah. So if I want to draw this figure, I know that this coefficient of or denominator of y is larger. So that is why it has to be a my bad. Sorry. So as the coefficient, I mean, denominator of y is larger, this has to be a vertical ellipse, something like that. We don't have to draw the exact ellipse. We just need to know how this is located and what are the focuses, what are the endpoints of major axis and endpoints of minor axis. So endpoint of major axis will be, in this case, 0, 4, and this will be 0, -4. End of minor axis will be 3, 0 and -3, 0. And vertex will always be 0, 0 for this. Right? So don't remember both the equations, just remember what is major axis, what is minor axis. Major axis is the larger coefficient, minor axis is the smaller coefficient. I mean, sorry, smaller denominator. Coefficient will be larger actually. 1 by 9 is larger than 1 by 60, but don't go for the coefficient. Just check which denominator is larger. If denominator of y is large, then simple, right? And one more thing we need to know is latus rectum and these focuses. How do we find out the focuses? And also one more thing is eccentricity. Yeah, काफी पढ़ाना पड़ जाता है, रिवीजन चलो फिर ये भी देख सकते हैं, द लेंथ बिटवीन f1 एंड f2 एंड आल्सो दिस, है ना. So हाँ जी, before we go to any further discussion, let's understand what is an ellipse. Do anyone know what is an ellipse? I mean, other than the squeezed form of circle wali definition. Can you define how do we form an ellipse? Okay, in that case, ellipse is the collection of all points, right, whose distances from two fixed points is whose sum of distances from two fixed points is same. So for example, in this case, if I take any point on the ellipse, right, let's take this point C. A, B, C, D, all 4 points lies on the ellipse, right? And these F1 and F2 are the focuses. So if I take any of these points, let's take C, and if I calculate the distance of CF1 and CF2, right? So this is the distance that I'm talking about right now. This and this. So if I find out CF1 and CF2, their sum will be something, right? I mean, sum will be some value. If I find out the distance of df1 and df2, or rather than df1 and df2, you take any point on the circle and find that distance, their sum will be same for every point. And if I take any other point, this, and let's call this point E, then EF1 and EF2 I mean, EF1 plus EF2 will be equal to CF1 plus CF2. Right, and this distance is also, by the way, equal to 2a. I guess it is 2a. Just give me a minute. Yeah, this sum is also equal to 2a, by the way. That is what I wanted to confirm. 2a is basically the length of major axis only. So this sum is equals to 2a, and this also helps you in finding out the coordinates of f1 and f2, right? And how do we do that? We can observe this also. So let's take these points. Okay, I'm removing these EF1 and EF2 for now, because I need to show you how to find out these focuses. So let's take, I mean, focus 1 and focus 2 will be at the same distance from the vertex, which is origin. So let's take f1 as minus c comma 0, then f2 will be your c comma 0, right? This is c comma 0 and this is minus c comma 0. This will be your focus. Similarly, in this case, your focus can be 0 comma c and 0 comma minus c, right? The equation, I mean, we can form an equation between c, b and a. If you observe here, then this is a right angle triangle. This distance is b, the length of semi minor axis. This is semi minor axis because this is half of the minor axis. So this is semi minor axis, which is b, and this is a. Oh, sorry, this is c, this length from this point O to F2, and this point, this length is a, by the way, because you can observe that the length of CF1 and CF2 both will be equal in this case, because C point is basically lies on the perpendicular bisector of F1, F2. So in this case, CF1 and CF2 both are equal. That is an added advantage. So CF2 basically will be equal to A, and B square plus C square is equals to A square is the connection or is the relationship between focus, major axis and minor axis. So you can find out this C as A square minus B square, root over A square minus B square. So one coordinate will be root over A square minus B square comma 0. Other will be minus times root over A square minus B square plus 0. So you should be able to locate the focuses of an ellipse. You should know about major axis and minor axis of ellipse. And for further, I mean, one more thing that we need to know is eccentricity. If you observe, this is E, right? So E is equals to C square, C by A, by the way. E can be calculated as C by A. You can notice this here if you haven't. I will also write this in that. So eccentricity, one more thing that we need to know. Eccentricity, which is known as E, Sometimes they will use this word. Eccentricity is this or this. So eccentricity E is represented as C by A, and C is connected to B and A with this equation. C square is equals to A square minus B square. C is basically helping you out in finding the coordinates of focus, right? And other than that, the last thing that we need to know is will be, lattice rectum. This is your, lattice rectum or double ordinate. Sorry, double ordinate is a different thing and lattice rectum is a different thing. Double ordinate is basically a line which is perpendicular to axis. So you have multiple double ordinates in parabola or ellipse or hyperbola, right? But focal chord, lattice rectum is that double ordinate which passes through focus. So lattice rectum is basically your that perpendicular line on axis which passes through focus, and we can find out the length of lattice rectum. Length of lattice rectum is 2e, twice e distance between focus and corresponding foot of the directrix, which can be defined as basically your 2b by a. Sorry, just give me a minute. Sorry, 2b square by a. Give me a minute, guys. You can note this down. This is the formula, 2b square by a. Yes. So the last thing is length of lattice rectum, which is twice b square by a. These things we need to know about an ellipse. So for example, for this ellipse, which we have written, the eccentricity is, so before eccentricity, we need to calculate C. C can be calculated in this case as C square is equals to 4 square minus 3 square, which will be 7. It means that C is plus minus root 7. Or you can also take C as root 7 only, because we will compensate for negative in the formula. So your focus will be 0 comma plus minus root 7. Root 7 plus minus root 7 comma 0. And then if I want to find out eccentricity for this, eccentricity will be root 7 divided by a, which is 4. And length of lattice rectum for in this case will be twice b square is 9, a is 4, so it should be 4.5 units. Right? These things are important for an ellipse. Don't remember that this is, don't remember the equations separately. Just remember that whichever denominator is larger, we call the corresponding name. And how do we find out eccentricity, C, and length of lattice rectum? These are the formulae for them, right? Okay. So now I believe that you are done with 3 figures, and we are also left with guys, are you free this Thursday or somewhere? Can I take a class tomorrow? Oh, bhai. Guys, can I take a class tomorrow?
Yes.
When
If Acha Shahid, okay. So can I take a class tomorrow at 7:30? Manish Shahid, here is what, 9:30 or what? I mean 9. Tell me the 10 p.m. Oh, 10 p.m. After 10 p.m. the class will be very difficult. I mean, I am available, but I don't think everybody here will be available. Is everybody okay if I take a class from 10 tomorrow? Not a 1.5 hour class, just 1 hour class. I wanted to,
10 p.m. India.
yeah, 10 p.m. 10 p.m. Indian timing.
Okay,
10 to 11. Just 10 to 11. We just want to revise this coordinate geometry. क्योंकि अभी स्ट्रेट लाइन बचा है और थोड़ा सा हाइपरबोला भी बचा है, बट स्ट्रेट लाइन तो थोड़ा बड़ा है यार, मतलब स्ट्रेट लाइन पढ़ाने के लिए मेरे को एक क्लास लगेगा, तो it's not like you will be able to complete straight line in 10 minutes. No. ठीक है, तो I'll tell you, we by the way will need straight lines again यार. I mean all of these curves in differential